Hi, let's talk about reactivity. So kind of interesting, I've given you your really quick, easy rule of thumb that you can memorize, and then I'll show you the why behind it. So metals, their reactivity increases as you go down the group. So for example, group 1, alkali metals, they are very reactive with air and they are very reactive with water. So if I were to put sodium, a pea-sized piece of sodium in water, it turns into a bottle or into a ball and it kind of spins on top of the water. It reacts with the water, makes a little noise as it spins on top of the water, and after about 30 seconds it would be reacted. Now, if I take that same amount of potassium, drop it in water, it's even more reactive. It is going to explode. It turns into fire on top of the water, and within 7 seconds is completely reacted with the water. If we were to put that amount of cesium in water, we could have situations where it's so exothermic, it reacts so quickly that it would actually explode the beaker. It would break the glass of the beaker. So as you go down the periodic table for metals, the reactivity increases. Now remember, in groups we have similar chemical and physical properties because they have the same ending in their electron configuration. Notice what I put right here. Sodium is a neon 3s1 and potassium argon 4s1. Every single alkali earth metal ends in s1. That's why they have similar chemical and physical properties. But those properties are augmented with each addition of another energy level. I'll come back in just a second and say why. Okay, so let's shift. Let's come over to nonmetals. So here's my group of nonmetals right here. Nonmetals, their reactivity increases as you go up the periodic table. So if we're looking at the halogens, they have this great ability to attract an electron. They are going to have that property of attracting electrons, high electronegativity, high electron affinity, that increases as you go up the periodic table. So whatever properties, chemical and physical, that you see in nonmetals, the augmented, the very exaggerated, stronger chemical and physical properties are going to be at the top of the groups. Okay, so here's the reason why, and we can see it with the electron configuration. Let's first talk about metals. So you know, as we go down that group, the metals are going to have high, I'm going to put a really high reactivity. This comes from Coulomb's law. Coulomb's law. So the reactivity here is going to be losing an electron. Remember, metals, cations, lose electrons. And the further away that a valence shell is, the easier to remove that electron, therefore the more reactive that it is. So if I'm looking at sodium and potassium, sodium is valence shell 3s1, potassium 4s1. Coulomb's law, the greater the distance, the smaller the energy. So it takes less energy to remove that electron from the fourth energy level, so it reacts faster, quicker, more powerfully. In turn, because the 3s is closer, there's a greater attraction between that positive nucleus and the negative electron in the third energy level, is going to be harder. It takes more energy to remove that electron. So the property of reactivity isn't as strong, it isn't as great. So that would be a lower reactivity. Now, if we look over here at our anions, so the nonmetals, they're gaining electrons. This is going to be justified by effective nuclear charge. Sorry to write over the periodic table. Effective nuclear charge. So for this, you're going to have a greater effective nuclear charge because you have a smaller atom, which is also related to Coulomb's law. So remember, effective nuclear charge, that increases with the power of the proton, and it's the proton acting on that valence shell. So if the valence shell is closer to the proton, that negative is closer to the proton, then it's going to have greater reactivity, greater ability to attract an electron. So because we have the highest electronegativity for the fluorine, because of effective nuclear charge, Coulomb's law, the size of the atom, it has a greater ability to attract an electron. because this has a greater ability to attract an electron, those chemical and physical properties are going to be strongest at the top of the group. So you can use both effective nuclear charge and Coulomb's law when you're talking about reactivity going up the periodic table for nonmetals, greater ability to attract an electron. And there you have reactivity. Have a wonderful day.